Okay, so today we'll start as a very first lesson on momentum as a vector. The first unit of Physics 30 is momentum and impulse. And for the first part of it, we will treat momentum first as a vector, and then we will see different approaches into this momentum as a vector. Now, momentum, it is known that if the object has a mass and it is moving, it has momentum. So when we are saying momentum, momentum is a vector quantity because it is the product of mass and the velocity of the object that is moving. So on this case, m is the mass of the object in kilogram, and v is the velocity of the object. P is known to be momentum. Now, even if you see it from this relationship, you can see that mass is a scalar quantity. In order to fully identify, we just need to state the magnitude and the units. And in this case, the units must be in kilograms. And velocity, on the other hand, is a vector quantity. And we know that in order to fully describe a vector quantity, we need to identify two parts, magnitude with the units and the direction. So therefore, we can say that momentum, that is the product of a scalar and a vector quantity, is a vector quantity as well. And on this case, not only is a vector quantity, but we can say that the direction of this vector quantity is the same as the direction of the velocity. So in other words, if you know the direction of the velocity, you know the direction of momentum. Okay, if I'm saying that an object with mass 3 kilograms is moving into with velocity of 3.5 meters per second going north, and I'm asking what is the direction of momentum, then you do not even have to think about it, but you just say that the momentum has a direction going north. Okay, so the direction of the velocity and the direction of momentum is the same. If you know one, then you know the other. If you know the direction of the momentum, then you do know what is the direction of the velocity. Is this clear? Now, considering the fact that the mass of the object is in kilograms and the mass of the units of the velocity is in meters per second, so we can draw the conclusion that the units for momentum are kilograms times meters per second, or kilograms meters per second. Now we are saying that momentum is a vector quantity. And as a vector quantity, we have repeated it over and over again that in order to fully describe it, we need to have the magnitude and the direction. So let's work through some examples when we are calculating momentum and when we are calculating the velocity or the mass by knowing the other two. So let's suppose that we are dealing with example 1, when we have an object with mass, an object, a block, usually is a sphere, a car, an object with mass 3.50 kilograms that is moving with a velocity of 32.5 meters per second at 25 degrees north of west. And we are looking for what is momentum of this object. Now, based on the fact that momentum is the product of mass and velocity, we can say that momentum of this object with mass 3.50 kilograms and a velocity of 32.5 meters per second at 25 degrees north of west will be 113.75 kilograms meters per second at 25.0 degrees north of west. But since what we have here is 3 significant digits all the way through, then we can say as the final answer for our momentum, or the momentum of this object with mass 3 will be 114 kilograms meters per second at 25 degrees north of west. Okay, good. Now, let's go one step further on this question. So this is momentum, which graphically or in northeast, southwest axis can be represented as a vector that is between the north and west, and it has a magnitude of 114 kilograms meters per second. And which one is angle 25 degrees? Is the angle with west or is the angle with north? West. It is the angle with west, because when we read a vector in English, we go from left to right, but when we display the vector into the northeast southwest axis, we start from right to left. So we say that we are at west and we are going toward north at 25 degrees with a magnitude of 114 kilograms meters per second. Now let's figure out what is the horizontal component and what is the vertical component of this momentum. Now, when we are doing this, we are working as this is a simple vector, as what we have done all the way up to when we were doing the science basics questions. So we are creating a triangle, a right angle triangle that includes the given angle. And whatever is along the horizontal will be considered as the horizontal component of the vector. And whatever is along the vertical will be considered as the vertical component of that vector. And now using and ka, so sine and cosine, we will find the horizontal component and the vertical component. So in order to find the horizontal component, since it is the adjacent of the 25 degrees, so will be cosine, so will be 114 times cosine 25 degrees. And I have an answer here saying that it is 103 kilograms meters per second. You can say either negative, or you can say 103 kilograms meters per second going west. We prefer the negative and positive sign just because we are having using this into the table of component later on. So we prefer to stay to the negative sign, but both definitions are right. And then when we are calculating the vertical component of momentum, then we will go 114 times sine, since it is the opposite of the 25 degrees. And I have an answer here being positive 48.3 kilograms meters per second, or you can say 48.3 kilograms meters per second going north. Next. So another example will be when you are finding what is the velocity of an object, knowing the momentum of this object and the mass of the object. So if we have an example like example 2, saying that an object with mass, I will just have a large one. Let's say that this is a car and is with a mass of 1,200 kilogram. It has a momentum that is 5.82 times 10 to the power of 3 kilograms meters per second at 50 degrees south of east. What is the velocity of this object? So now it is important to use the fact that velocity and momentum has the same direction, which means that we don't even have to think about what is the direction of the velocity. We just have to find the magnitude of the velocity. Based on the relationship, and this is as a result even of the relationship. So based on the relationship, we know that momentum is mass times velocity. And from here, we find that the velocity is momentum over mass. But since those two have the same direction, then we can simplify our calculations into magnitude of the velocity, or just simply the velocity, is equal to the magnitude of momentum over mass. So you can say that in this case, we'll have 5.82 times 10 to the power of 3 kilograms meters per second over mass, that is 1,200 kilograms. So kilograms and kilograms are canceled out. And then we will have the magnitude of the velocity as you will find that the magnitude of the velocity is 4.85 meters per second. And when you are stating in a written question as to what is the velocity, you will state it with the direction, because the velocity is a vector quantity, and we'll have 4.85 meters per second at the same direction as the direction of the momentum, that is 50 degrees south of east. Let's see now another example when we are figuring out what is the mass. So this will be example 3. Let's suppose that we have a situation like this, and you will see this wording even in your practices, in your quiz, and in your unit test and diploma. So you are saying, or the question is saying, the magnitude of momentum is 5.82 times 10 to the power of 3 kilograms meters per second. And the velocity is 8.35 meters per second at 22 degrees west of north. What is the mass of the object? So you notice here that just to make it easier for us, We are not stating the direction of the momentum, and you may see questions that the direction of velocity is not stated, just for the simple fact that the direction of the velocity and direction of momentum are the same. So when you are stating one, you know the other one. Okay, now based on the fact that momentum is equal to mass times velocity, since we are finding a scalar quantity on this case, we can say that mass will be equals to magnitude of momentum over magnitude of the velocity. So this will be 5.82 times 10 to the power of 3 kilogram meters per second over 8.35 meters per second. So we kind of ignore the direction on this case. Therefore, the mass of the object will be, so mass will be what the calculator is giving me as 697.005988 kilograms. However, in our calculations, the lowest significant digit is 3, and since we are doing multiplying here, we will follow that the final answer follow the rules for significant digit when we are multiplying, which is go with the lowest number of sig divs. The final answer will be 697 kilograms. So now on the example 4, I think it is, we have an object with mass 5.82 kilograms. I don't know why 5.82 is stuck on my mind. And it is moving with a velocity of 63.5 kilometers per hour. At 37 degrees south of east. So if we are plotting into northeast-southwest axis, the velocity at 63.5 kilometers per hour at 37 degrees south of east will be a vector that is between south and east, and the angle that is formed is the angle with the east axis. So this will be 37 degrees. This angle will be 37 degrees. And the magnitude or the length of the line segment that represent the vector will be 63.5 kilometers per hour. However, usually momentum is expressed into international system units, which is kilograms meters per second. So the very first thing that we have to do in this case is to convert the kilometers per hour into meters per second, which means that what we will do is that is known as a unit analysis. So we have 63.5 kilometers in 1 hour. And now in order to cancel, let's say, kilometers, the kilometers in that ratio of 1 should be where? In the numerator or on the top, or in the denominator or in the bottom. So then we'll have here 1 kilometers, and the units that we want, has are meters. So how many meters there are in 1 kilometer? Good. So it will be 1,000 meters. So kilometers and kilometers is canceled out. And by just doing this, multiplying by a ratio of 1, because this is what unit analysis is, the units that you have here are meters per hour. However, we don't want those units, we want meters per second. So now we will convert the hours into seconds. So again, we will multiply it by a ratio of 1, and we want to cancel the hours here. Where should the hours be? In the numerator or on the top, or in the denominator or in the bottom? they should be in the numerator, because as I said, we have to, in order to cancel the units, they have to be in two different places. If one is in the denominator, then the one that you are multiplying by has to be in the numerator. If the one that you have is in the numerator, then the one that you are multiplying by has to be in the denominator. So we have 1 hour here, and in 1 hour we have how many seconds? Then hours and hours are canceled out. And in terms of the unit, what do you have here after you are multiplying with the second ratio of 1 is meters per second, which are the units that we want to have the velocity at. Now, through calculations, we will have a value of the velocity of 17.63 and 8 repeating meters per second. And if we are expressing this into the velocity being a vector, then we should say that the velocity is now 17.6 meters per second at 37.0 degrees south of east. However, the rounding is always done at the very end. So this will be something that if I'm asking you what is the velocity, if I'm asking you simply what is the conversion from kilometers per hour into meters per second. But in the case when we have to calculate momentum, the rounding will happen at the very end. So now the momentum will be 5.82, momentum being a product of mass and velocity will be 5.82 kilograms times 17.638 repeating, whatever is the exact value that we have from our calculations, meters per second at 37.0 degrees south of east, because the rounding is done at the very end. And now momentum will be, so momentum, what the calculator is giving us is 110.658 and then 3 repeating kilograms meters per second at 37 degrees south of east. However, when we are considering the correct significant digits as the final answer, unless otherwise is stated, if I'm asking you to record it to 1 digit after the decimal point, then you will go with 102.7. But if we are considering the correct significant digit, then will be 103 kilograms meters per second at 37 degrees south of east. Which means that what we have in terms of the displaying it in northeast southwest axis will have a vector that is between, again, between south and east. This is momentum. And the angle created with the east axis is 37 degrees. The magnitude of it is 103 kilograms meters per second. When we are finding the horizontal and vertical component, we'll do the same thing, exactly the same thing as we did even in the example that we had here, and what we have done at every vector quantity. We are creating the right angle triangle that includes the given angle, and whatever is along the horizontal will be the horizontal component, and whatever is along the vertical will be the vertical component. And then using sine and cosine, sine being opposite over hypotenuse and cosine being adjacent over hypotenuse, we'll find the horizontal and vertical component of this vector. because even though that this is a new concept, is momentum, something that you haven't seen before, still it is a vector, and we will use it. We will use the same concepts as we have used for any vector prior to this. So the horizontal component of this vector is a positive one, and it is 103 kilograms meters per second times being adjacent will be cosine. So cosine 37 degrees. And for the vertical component, since it is going towards south, will be negative 103 kilograms meters per second times sine 37 degrees. Make sure that the mode of your calculator is on degrees, and then you will have the values. For the horizontal will be positive 82.3, considering even the significant digits, and for the vertical will be 62, negative 62.0 kilograms meters per second.